So you crack open just about any electronic gadget, and you're met with this tiny city of components, right? Well, among all those little pieces, two of the most common are carbon film and metal film resistors. Now, they might look almost identical, but believe me, the choice between them can make or break your project. Today, we're going to dig into what makes them so different and, most importantly, how to pick the right one for the job.
You've seen them for sure. They're sprinkled all over circuit boards like electronic confetti. And while they look pretty simple, choosing one type over another can completely change how your project performs. We're talking everything from a high-end audio amp to a super sensitive scientific instrument. Yep, they're called resistors, and honestly, they're the unsung heroes of the electronics world. Without them, the whole beautiful dance of electrons that powers our modern life would just fall apart into total chaos. Think of them as the traffic cops of the circuit world, making sure everything flows just right. So what is their number one job? Well, in a nutshell, a resistor's job is to resist the flow of electricity. It's kind of like a kink in a garden hose. You need more pressure, that's your voltage, to get the same amount of water, your current, to flow through. And this one simple idea is the key to everything they do. Okay, so even though they look super simple, resistors are doing some incredibly important work inside all of our gadgets. Yeah, they might be easy to overlook, but they are far, far from unimportant. And they are definitely not a one-trick pony. I mean, they do everything. They cut down the current to protect sensitive little components like LEDs, they split up voltages to create precise reference points in a circuit, and they even team up with capacitors to create timers. They are the ultimate utility players in the game of electronics. All right, let's meet our two main contenders in the ring today. We're talking about the most common through-hole resistors, and that just means they have those long legs designed to poke through holes in a circuit board. You can think of them as two different specialists, each with their own personality and their own set of skills. First up, in this corner, we've got the carbon film resistor. This guy is the old school workhorse, the classic. It's been around forever. It's tough, it's cheap, and it just gets the job done in a massive range of situations. So how's it made? Well, you start with a little ceramic rod, and you deposit a super thin film of carbon all over it. Then, to get the exact resistance you need, a laser zaps a spiral groove into that carbon film, kind of like the threads on a screw. This makes the electricity take the long way around, which dials in the resistance perfectly. Pretty clever, right? And what's this workhorse's personality like? Well, for one, carbon film resistors are cheap, which is a huge deal if you're making thousands of something. They're also surprisingly tough when it comes to handling sudden surges of power and high voltage. And they've got this special character when it comes to audio that some people absolutely love. We'll get to that. And in the other corner, we have the metal film resistor. This is the modern, high-tech specialist. If the carbon film is the rugged, all-purpose pickup truck, the metal film is the high-precision surgical tool. It's built for one thing above all else: accuracy. The construction is pretty similar, but with one critical difference. Instead of carbon, a very, very thin and uniform layer of a special metal alloy, usually something like nickel chromium, is put onto a super pure ceramic core. And that material is the secret sauce. It's what gives this resistor its incredible precision. So what are its superpowers? We're talking crazy high precision, with tolerances, that's the margin of error, as tight as 0.1%. They are rock-solid stable over long periods of time and across big temperature swings. And here's a big one. They generate almost zero electrical noise of their own. All right, we've met the fighters. Now it's time for the main event. Let's put them side by side and see how they really stack up when it counts. This table really tells the story. When it comes to precision, metal film wins, no question. Same for temperature stability. Its resistance value barely budges when things get hot or cold, which is definitely not the case for carbon film. Metal film is also the undisputed champ of low noise. But check out those last two rows. Carbon film is cheaper, and, this is important, it's way better at handling a sudden jolt of power. That's because its thicker carbon element can physically soak up that energy burst better than the delicate metal film can. So let's say you're staring at a circuit board. How can you tell them apart in the wild? Well, it's not a 100% guarantee, but as a general rule, carbon film resistors are that kind of khaki or greenish color and usually have 4 color bands. Metal film resistors, on the other hand, are very often blue and tend to have 5 color bands to show off their higher precision. So, after all that, which one's better?
Well, the real answer is it totally depends on what you're doing. The best resistor is always the one that's right for the specific job you need it to do. Okay, let's get practical with a real-world example. Imagine you're building a super sensitive weather station. The outside temperature is going to be all over the place, but you need your measurements to be dead-on accurate all the time.
This is a classic problem. Take it from an engineer named John. He tried to save a few pennies with carbon film resistors, but he found his temperature readings were drifting all over the map, making his device totally unreliable. The moment he swapped in the stable metal film resistors, problem solved. The readings were solid as a rock.
Now, let's flip the script completely. Let's say we're building a vintage-style tube amplifier for a guitarist who wants that classic, warm, analog tone. In this case, pure technical perfection might actually be the enemy. Maria's story is the perfect example. She built an amp with those perfectly quiet and precise metal film resistors, but it sounded, well, too clinical, too sterile. So she swapped some of them out for carbon film types. The little bit of noise and harmonic distortion they added, which are technically flaws, gave the amp a warmth that she loved. It's a fantastic reminder that sometimes taste beats the spec sheet. So when you're digging through your parts bin, faced with this choice for your own project, how do you make the right call? It really just boils down to a simple 3-step process. First, ask yourself, what is my number one priority? Is it pinpoint accuracy, saving money? Second, think about the specific job this resistor is going to do. And finally, based on those answers, pick your champion. It's all about matching the resistor's personality to the job at hand. But look, if you just want a simple rule of thumb to live by, here it is. For most general-purpose projects you're going to build today, the 1% metal film resistor is the new standard. Their price has dropped so much over the years, and their performance is so good that they're the safe, reliable choice unless you have a very specific reason to go with carbon film. And that leaves us with one last thing to chew on. As all of our gadgets keep getting smaller, faster, and way more precise, what does it mean for the future of these two old rivals? You know, while the precision of metal film is clearly taking over, that unique character of carbon film will probably ensure it always has a special place in electronics. It's a great reminder that sometimes the best component isn't the most perfect one, but the one that's just right for the job.